Hello friends, welcome back to Simply Study. In this video, I will explain you the solution of Basic Electronics paper of GTU November 2018. The topics which are asked in the paper are very important, and instead of just reading the solution, you can find a video solution of the GTU papers over here. You can also download the GTU question papers and the solutions in a PDF from the links mentioned below. So let's start with second question. Question 2 is a compulsory question. Question 2a states, design and explain basic NAND gate using DTL logic. This question carries 3 marks. Let us first see what is a basic NAND gate. NAND gate comprises of an AND gate followed by a NOT gate. Hence, output will be complement or opposite to that of AND gate. This is the truth table of a NAND gate. You can clearly see how the output of NAND gate differs from AND gate. This is because the succeeding NOT gate inverts the output of AND gate. This is a 2-input diode transistor logic circuit. As the name suggests, it consists of diode and transistors. X is the output terminal and the circuit is given 5V VCC. Let us see how the circuit works. When both input A and B are given with 0V, both of the diodes are in forward bias condition, that is in the on condition. Supply voltage will get passed to the ground through diode D1 and D2. Entire supply voltage plus 5V will ideally drop across resistor R, and hence base terminal of transistor T will not get enough potential to turn on the transistor, and hence the transistor will be in off condition. As a result, supply voltage plus 5V will appear at output terminal X, and hence output X will become high or logical 1. Now if either of diode D1 and D2 is applied with 0V, the same thing happens as in these cases also. The supply voltage gets a path to the ground either of the forward bias diode. In that cases also, the output will be logical high or 1. When both of the inputs are given with plus 5V, that is logical 1, both of the diodes are in off condition, and hence supply voltage will appear at the base terminal of the transistor T, which makes it switched on, and supply voltage gets a path to the ground through these transistors. Ideally, entire supply voltage plus 5V will drop across resistor R dash, and output terminal X will get ideally 0V, and hence the output is considered as logical 0. Hence, the output is only 0 when and only when both inputs are plus 5V or logical 1. Let's move to next question. Question 2b states that explain NAND gate, XNOR gate and NOT gate using their truth table, logic symbol and equation. Let us see the NAND gate. The logic symbol depicts a 2-input NAND gate. As it is noticeable, the truth table of a NAND gate is a complement to that of an AND gate. The Boolean equation can be represented as AB complement is equal to A complement plus B complement. Let us see the NOT gate. The logic symbol depicts a single input NOT gate. The output of the NOT gate is complement to its input. The Boolean equation of a NOT gate can be given by Z is equal to X bar. The exclusive NOR gate is a combination of the exclusive OR gate and the NOT gate, but has a truth table similar to the standard NOR gate, in which it has an output that is normally at logic level 1 and goes low to logic level 0 when any of its inputs are at logic level 1. However, an output 1 is only obtained if both of its inputs are at the same logic level, either binary 1 or 0. Let's move on to the next question. Question 2c states that draw and explain bridge rectifier. Explain advantage and disadvantage of bridge rectifier over full wave rectifier. This question carries 7 marks. Here is the diagram of a bridge wave rectifier. When input AC signal is applied across the bridge rectifier during the positive half cycle, diodes D1 and D3 are forward biased, allowing the electric current to flow, while D2 and D4 gets reverse biased, hence blocking the current. On the other hand, during the negative half cycle, diodes D2 and D4 are forward biased, allowing the electric current to flow, while D1 and D3 gets reverse biased, hence blocking the current. Let's move to the optional part of question 2C. Question 2C states that write a short note on biased clipper circuit. Positive diode clipper. In a positive clipper, the positive half cycles of input voltage will be removed. The circuit arrangements for a positive clipper are illustrated in the figure given. As shown in the figure, the diode is kept in series with the load. During the positive half cycle of the input waveform, the diode is reverse biased, which maintains the output voltage at 0 volts. This causes the positive half cycle to be clipped off. During the negative half cycle of the input, the diode is forward biased and so the negative half cycles appears across the output. Sometimes it is desired to remove a small portion of positive or negative half cycle of the signal voltage. For this purpose, a biased clipper circuit is used. In figure 2, it may be observed that the clipping takes place during the positive cycle only when the input voltage is greater than battery voltage. The chipping level can be shifted up or down by varying the bias voltage. In figure 3, clipping takes place during the negative half cycle only when the input voltage is less than bias voltage. The solution of other questions of this paper and many other papers are available on this channel and they are uploaded periodically. Thank you for watching Simply Study and don't forget to like, share and subscribe.